Hey everybody. Round two. We've got nice weather, so hopefully this will work out really well. And the moon isn't going to be too bad. Billions and billions of stars ask, will this edited version of this live stream be available later? We're not going to make it unlisted, so it'll just be public once the live stream is finished. So for the 25 of you that are currently watching, and I'm sure more will trickle in a bit, the plan for tonight's live stream is I'm going to image a giant list of objects, but the trick is that each one of the things that I'm going to be observing is going to be a little bit farther away, and so a little bit farther back in time. So we're going to start with things that are relatively nearby, and then we're just going to keep moving outward farther and farther into the universe. The moon is still a little too low for me to be able to image, so that would be the closest thing that I would look at, but the moon is, so maybe we'll come back around and we'll sneak the moon in when the moon has gotten a little higher. But I'm going to start with some asteroids, some comets, we'll move to some planets, and then we'll move out to nearby stars, star clusters, nebulae, galaxies, and hopefully at the very end we'll get to some quasars. So we should go from things that are just a couple of light minutes away from us to things that are hundreds of millions of light years away from us tonight. So that's why we're calling it the time travel stream. And this is hopefully this will be a lot of fun. So I've put a link, I've pinned a link up to the top of the chat. And that is a link to a Google Drive folder that all of the images are just going to get automatically dropped into that folder as we go. And so I'm going to sort of, as we take pictures, the pictures will just get dropped into that folder. And before I do any processing or anything, so you just see them as they come up. Unfortunately, I don't have a good way to give them proper names. So if I have a little time, I might actually go and name the images in the Google Drive folder, or otherwise they'll just remain as big, long strings of numbers, and that's just what the telescope spits out. So normally I take requests, but I'm not going to take requests tonight unless we have like a lot of extra time. I'm going to go through these objects in order, but I'll give you some colorful information about the objects that we're looking at, and answer any questions you have about astronomy or the object that we're looking at. And this is an experiment. Hopefully this will work. I don't know. Let's have some fun. Okay, so first, you can see here, I've got the wrong name, but the telescope is pointed, at the first object that we're going to look at, and that is asteroid Eunomia. And that is 10 light minutes away from us. So in other words, oops. Let's see if I can get that there. Let's see if that works. Okay. So let's take a picture. And let me know if the images are like a little out of focus or anything. So we'll take a very quick image. So this object, asteroid Eunomia, there you go, was discovered in 1851, and it is the largest stony asteroid that we know of. It's about 268 kilometers across. And so I don't know which one it is. If you see, we're taking a picture now and there's like a star in the sky, and in theory the telescope is centered right on this asteroid. You're going to see this battery critical thing come up, and that's because we had to disconnect the battery of the telescope so that we could then restart it just by turning it off and turning it back on again. And so it thinks that it doesn't have a battery, and yet it never seems to run out of power, and it's very confused about that. So that's probably a long enough exposure. So we'll stop there and see how that goes. And then I'll download, I'll save the image, and then I'll put it in, and then we will go from there. Asteroid Eunomia. Don't go mining there. All right. So just let's see if this works. Oh no. We're seeing double. So the telescope must have gotten jiggled. I wonder how. Huh. Okay. I'll take another picture of it then, because that's not good. And so the image will get automatically dropped into the folder in just a couple of seconds. Yeah, so there it is there, but like I said, I'm going to take another shot of it because that's ridiculous. All right, that'll be enough. Now it's completely remote, so there's no way that I could have like jiggled the telescope when I stopped the imaging. So we'll see what that looks like. I'll try opening it up. That download. That's better. Okay. Yeah. So everything's seeing double. So we'll go with this other version instead. And maybe we will edit it down. I'm not sure if Anton will actually want to spend any time editing it. All right, so we got the new version. It'll just be in the Google Drive in a second. So this is the tricky part about imaging stuff in the solar system. I don't know if I don't know what we can see. Like there's a lot of experimentation that's going on tonight. So just stay tuned. Okay, there we go. So which is the object? Which is the asteroid? I have no idea. My point here is that it's full of stars, right? Here's the full screen version. Maybe it's right there. The problem with asteroids is they look like stars. There's no way to know. Like around here somewhere. Yeah, I don't know. So there you go. That is 10 light minutes away, and that is an asteroid. All right, let's move on. We're going to go to a comet. We're going to go to the only sort of bright comet that's in the sky right now, which is C22 Atlas. So we'll search for that. C2022 E2 Atlas. And again, I have no idea. It's a fairly faint comet now, so it's probably not going to look great. Take another picture in a while and we'll see which one moved. Yeah, there you go. That's a good idea. So we'll take another picture and then we'll be able to do a blink back and forth to see if we can find out any information about if we can spot which one is the asteroid that's moving. I mean, it would work. It would actually work and you would actually see the asteroid moving. So let me see if I can rename that and I'll delete the other one. Asteroid Eunomia. All right, there we go. And I'll delete that one just so people don't get confused. All right, so I have no idea whether this comet is going to work. I tried taking a picture of it a couple of days ago. And it could just be that it's so faint at this point that it's not even visible. It's like 13th magnitude, which is fairly faint and probably very diffuse. Like a lot of the objects that we're going to be looking at are going to be much brighter than 13th magnitude. There it is. Okay. So Comet C 2022 E2 Atlas is 27 light minutes away. In other words, this comet that we're seeing here, just in the foreground, you can see it. Let me see. You can't see it yet. All right. There. So you want to look at the object on the right, which is the telescope that's taking the pictures, and you can see the comet there, just right in the middle. But I definitely see it. It's just not very bright. So, are you talking to Bray? Is Bray here? So this is going to be, that's Comet Eunomia. So this will be Comet C22 Atlas. Again, 27 light minutes away. Oh, hey. Hi, Bray. Thank you so much for making this possible. I really appreciate it. All right, that'll do. I think we got it. We done? Oh, it's still processing. Okay, hold on. Let me stop it. I'm on. And I haven't actually been tracking this one at all. I know a lot of people have taken pictures. Oh, I see the tail. Okay. All right, and I will update the image name when it downloads into the Google Drive. And I have no information about C22 Atlas. Let's see. There we go. So there's the... Okay. So, I don't know if you can see it there. I'll zoom in on it. There you go, Comet. Well, it's happening. It's there. I see it. And I'll go to the other view. Yeah. So there you go. A comet. Whew. That's good. And I'll change the name for this. Awesome. Okay. All right. So next on our journey, we are going to go to Jupiter, which should be fun. Now, the good folks at Starfront are building a planetary setup. So right now, Jupiter is going to look very, very small because it's the Celestron Origins is it's a deep sky telescope. It's not really designed for looking at planetary stuff. It does a really good job of the moon, but it's really not it's too wide of a field of view to show small things like planets. So you need a totally different telescope to be able to do that. So you can see here, this is the sort of virtual version of the sky that the telescope is. I gotta remember to go back to this view. Okay. You can see where the telescope is going. And so right now it's zooming in on Jupiter. And so now it's got Jupiter, and I will take a picture. And I might have to use a different trim. It takes a totally different trick to take a picture. So you can see it's completely overexposed right now. So I can change the exposure. Let me turn off the auto. Let me try doing a snapshot. See what it does. Nope. Okay. Nope. So it's still super overexposed. So we'll do this manually. So let's turn off the auto exposure. Let's bring the exposure down. So it's 30 seconds right now, which is way too long. So Jupiter's getting completely overexposed. What's cool is you can see the moons of Jupiter. So we'll bring the exposure down to say 5 seconds. 4 seconds. Oops. try 5 second. I think that's still too long. Okay, we'll try a 1 second exposure. Still too bright. If I try taking an image, will it? No. Still too bright. Okay. So now we'll go. Into the milliseconds. Snapshot mode. Okay, all right. I've done Jupiter before. Well, let me do... Okay, there we go. 5 mil. Okay, so it's taking a picture. All right. 30 milliseconds? Yeah. Perfect. There's Jupiter. I love it. That's the one. And I will bring it in and I'll blow it up. We want shorter than that even. That's 5 milliseconds. Yeah, we'll see how that looks. All right, so that's going to be Jupiter. And Jupiter is currently 34 light minutes away from us. Did you take your picture? Save the camera roll. How come it's not showing up? Weird. Okay. Well, you saw Jupiter. It's not going to be great. How do I get that image off? Yeah, unfortunately, Jupiter is just too bright and too small for this telescope. But there it is. So I'm going to move on. Next, we'll try Mars. It might be too low on the horizon. Yeah, you can see where the moon is just down on the horizon. So here's Mars. Oh, that's cool. I can get the beehive. Awesome. No, that is not the best view of Jupiter that is possible. That's the best view of Jupiter that is possible with this telescope. So... let me try. And there's Mars. And it's not saving to my camera roll. Weird. Okay. All right. So there's Mars. Mars is... actually, Mars is closer. Mars is the closest object I should have pointed at because it's only 6 light minutes away from us. This whole thing is falling apart. All right, now we'll do Saturn. So we'll move over to Saturn. And we'll get through all the stuff that that this telescope is bad at, and we'll move to the stuff that this telescope is good at. I wonder why it's not showing the images. Huh. Okay. And you see Neptune is also in the sky. I'm going to skip Neptune. I think you got the experience of what it's like to image planets. Noor Ahmed, what would be a really good telescope that as an average citizen can get for the average citizen marketplace to view solar system planets very clearly? I always recommend getting a Dobsonian telescope, like a 4-inch or a 6-inch Dobsonian telescope is going to be your best shot. So there is Saturn. Can you see it? What we call Saturn. Okay, let me see if I can get these. Turn off snapshot mode. Okay, let me try taking a picture of Saturn. What is cool about this picture, I don't know if you can see it in the image, but you can see its moon. You can see Titan there in the picture. No, totally overexposed because it's doing a 10-second exposure. Okay, let me try a 1-second exposure. With an ISO of 200, maybe I can turn the ISO down. Yeah, the picture of Saturn won't download for some reason. So the picture of Jupiter, the picture of Saturn. So I'm going to try grabbing this image of Saturn, or what we will call Saturn. I hope Bray's taking notes. This is why we need a planetary scope as well. All right, so let's move on outside of the solar system. So we're going to move to some stars. Oh, good. Bray was just out getting photos with the planetary scope. So it shows it's happening. So there's the image of Saturn is on the Saturn. And I'll download that and I'll show you what it looked like. Now, I could have brought the exposure down, but it wanted me to switch into snapshot mode. So there's Saturn. And Saturn is 81 light minutes away. So a little over an hour. The light from Saturn is 81 light minutes away. Okay, so that's enough of the bad pictures. Now we'll move on to the good pictures. So this is a... yeah, we're on... Okay, so it's a star called Eta Cassiopeiae. Cassiopeiae? And so what's cool about this star is that it is a multiple star system. So it is it's a binary star system that's in the constellation Cassiopeia. It's got 2 stars. So one is very much like the sun, and the other one is a smaller K-type star. And this telescope has a very wide field of view, so it probably can't break them apart. But we will get to some binary objects that we can actually see. But what's nice about this one is it's only 19 light years away. So if you can see the image. I'm only doing 1 second exposures. Wow. Okay. All right. I gotta change that. But it's fine for stars like this. And we'll move on to the next one while this one's downloading. Okay. That's better. That's pretty cool. Cassiopeia. Well, it's Cassiopeia, but the stars, it's like Cassiopeia. I'm not sure. Maybe it's like a plural of Cassiopeia. All right, so we're going to move to another multiple star system, and this is Iota Cassiopeia. So I'll move over to Iota. This one, we should be able to see the multiple star system, which is pretty cool. And so this one is 140 light years across, 144 light years across, light years away. And so small telescopes can actually show the different stars that are orbiting one another. All right, so this time I'm going to change to a 5 second exposure. No, I'm not. I'm doing a 1 second exposure. Okay. I'm okay with that. No, I don't think we can see the multiple stars in this. I'll try zooming in. That'll do. 5 seconds of exposure. That's where Jodie's Foster lives. Probably. I'll put that there. Yeah, I've got Albireo in my list, so we'll try getting to Albireo and see if we can get that. Maybe I don't. Let's see if Albireo is up. Yeah, Almach is the next one, but I think it's too low. We'll see. I'm going to try zooming in and see if we can actually see the multiple. So this is the Iota Cassiopeia. And it's 140 light years away. And let's try zooming in. Yeah, I think I see it. It's a tricky observation, but I think you can see the multiple star systems. Yes, this telescope is best at very dim objects. So we'll try Almach. Now, we'll move on. I'll move on to the ones that I was planning. Oh, no, Almach is the next one. Okay, never mind. So we'll do this Almach next. And I'll do, again, 1 second exposures. Telescope is very fast. I should list what it is. Five seconds, that'll do. So Almach is 350 light years away. It's in the constellation of Andromeda, and it has 3 stars in the system. So the one that you can see, oh, it just didn't stop. Stop. And so the one that you can see is sort of the primary one, and it's a K star. And then there's a blue-white star that's part of a tighter binary system. So there's 3 stars in the system. And they're separated by 10 arc seconds, which should be good enough to be able to see in this telescope. But we'll find out. I'm learning what this telescope system can do. It's like the 3rd time I've done the live stream with it. And it is 390 light years away. So again, we are seeing the light from this star as it appeared 390 years ago. And I can't make out the multiple stars in that system. So let's move on. So now we're going to do a fairly famous one. Although this telescope isn't great for this either, just because the object is so big, and that's the Pleiades star cluster. Let's give it a shot. Like, it can't fit. It's so big. This is Starfront's telescope. So I don't own the telescope. They are lending it to me. And for this, I'll do longer exposure. Okay. So what's cool is with this telescope, it's automated and allows it to build up the image over time. And so we will sort of start and you'll get the first exposure, and then each following exposure will add a little bit of data, remove some of the noise, improve the quality of the image. And it's essentially stacking up the image in real time as it gets more and more data. So this first image, that's a 10-second exposure, and it's already like really dirty. And then you get a second exposure, and you can see a little bit more of the fainter nebulosity around the stars is coming in. And like it's really important to understand here that we are seeing images that are like, that's a 20-second exposure, and you're getting this faint nebulosity. This telescope is so fast. And really, it's just a question of how long do we want to run the exposure for. The longer, I could have this just go and gather light for an hour, but it would be a very boring live stream. But it's entirely possible. And so, like I said, it's such a large object that it doesn't fit in the field of view. Okay. Starfront is setting up a planetary scope for us to use. So at some point into the next couple of weeks, we'll have a planetary scope. Okay, I think that's enough. That's about 90 seconds of exposure. So I'll save that. And then I will share that image. And you're looking at now an object that is 444 light years away. And as legend goes, the Pleiades was used by ancient peoples as a way to determine how good your eyesight was. That, however many of the objects that you could see in Pleiades would sort of tell you just how much your vision had gone. And the stars are really young. They're only about 100 million light years, 100 million years old. And so when you compare, this is the kind of nebula that the solar system once formed in. And there were other stars around us like these stars in Pleiades. And then at some point over time, all of these three-body interactions with the stars eventually had all of the stars drift away from each other. And so this is kind of what our star system looked like. This is what our star system looked like 4.5 billion years ago, as the solar system was forming. All right, now we're talking. Okay, and I'll just put this full screen so you can see. And then I'll move on to our next target while you're taking this in. So next we'll look at Betelgeuse. Yeah, the stars in Pleiades are close together. I mean, they are a few light years apart from each other, but they are relatively close to each other. That's nice. All right, let's take a picture of Betelgeuse. I think I've got to go back to a 1 second exposure. Because it is just such a bright star. And now we're 642 light years away. And of course, this star is incredibly famous. One of the brightest stars in the sky. It's the shoulder of Orion. And so when you go outside and you find the constellation of Orion, Betelgeuse is very obvious. And of course, it became very famous in the last couple of years because it changed in brightness. It's a variable star just on its own, but it dimmed more than anybody was expecting. And, we still don't 100% know why it dimmed, but it's believed that like a cloud of gas, dust passed in front of it. People are always hoping like, oh, does this mean it's going to blow? Which would be cool. But we don't know when Betelgeuse is going to explode. Sometime in the next 1 to 100,000 million years. There we go. And of course, obviously, 600 and it could have happened 642 years ago. And if we see it happen tomorrow, it actually, the star went supernova 642 years ago. All right. Now let's look at our first nebula, and this is the Helix Nebula. Oh no, it's too low. Bummer. Okay, maybe it'll show up later. Let's go for the iris then. Okay. Yeah, the Pleiades constellation is on the hub of all of the on all the Subarus. So in Japanese, the name for Pleiades is Subaru. And so when you buy a Subaru car, you're actually getting that should be the only car that you buy, I guess, if you're into astronomy. All right, so we're going to go back to doing a long exposure. And this one, we're going to want to take our time with it, just because it's a fairly faint nebula, but it's kind of amazing. It's one of my favorites, but it's kind of tricky. So there's a bunch of different kinds of nebula, and we'll see all of them tonight, right? There are supernova remnants, there are planetary nebula, and then there are various kinds of star-forming nebula. And in the star-forming nebula, you have a couple of varieties. You have these sort of big ones that are often sort of seen as kind of faint red clouds. Those are emission nebula. But you get a kind where you have a very bright, hot star where the hot radiation is coming off that star. It's bouncing off of nearby clouds, and you get this reflection nebula. And there aren't a lot of examples of reflection nebula compared to the emission nebula. And this is one of the best because it really feels like you've got this star that is down inside this kind of cave, and you can just see the sort of pillowy nebula that's all around it. And so what you're getting is the nebula itself is very dark. It's not emitting light in the way that other nebula that we're going to look at are emitting light, but it is reflecting the light coming off of this star. And you really can't get this without that. So, and the nebula is about 6 light years across. So to sort of keep that in mind. And of course, we are 1,300 light years away from Earth now. So we are looking back in time. Oh, you know what I should do? I should like say things that happened 1,300 years ago. Oh, well. That'd be cool. I'll do that next time. All right. I think that'll be good. That's about 2 minutes of exposure time, and that should give us enough to see it. Now, obviously, you know, if I was trying to take the best picture that I could, I would do a 1 hour exposure. I would do a 2 hour exposure. I would set up the telescope every night for multiple nights and take, you know, more pictures every single night. But, you know, we got to keep moving. We don't have time for that. This is astronomy on the go. So I see it's already changed the name. Okay. All right. So if you can see what I was talking about here, you can see this star down at the middle of this nebula, and all of this bright material around it is coming from the reflection of this hot star. Say things that happened 1,300 years ago without context. All right, next. This is a tricky one, so we're going to do the Orion Nebula. The classic, famous Orion Nebula. If it's up, I hope. Yes. It has risen. Excellent. All right. Physics Police, you watched Pluto. Oh, great. Did you, and if you haven't already, watch Monster, which is made by the same group. Very different than Pluto. All right, we're going to be looking at a bunch of stuff in the Orion Nebula too. But we'll start with the famous. We'll look at the Running Man. We'll look at the Horsehead Nebula. Okay, let's take a picture. I'm going to reframe it. Right there. So now it's going to move the telescope to do the framing that I wanted. Or not. Oh, center here. Okay. That's cool. Okay. Hopefully there won't be any trailing. Yep, Running Man Nebula is on the list. Yep. This one's one. Look at that. That's crazy. That's a 15-second exposure. That's bonkers. Now this telescope is showing you what it can do. That'll do. Yeah. We'll save that. All right, I'm just going to have it download into the Google Drive. And then I'll put it up. It's full screen. To full screen. We'll go to the full screen. Let's see. And you see we got a satellite trail going through it. That'll do. Okay, don't get too comfortable. Now we're going to go to the Flame Nebula. Yeah, we got Starlinked. Now, if I was trying to be careful and actually take a good picture, then you could record all the separate frames. You can remove the frames that are, that have data glitches, things like that. I mean, we used to joke that they were Starlinks, but now, I mean, they're almost certainly Starlinks. They're the most common satellites by far. So. So the Flame Nebula. Oh, there it is. Start to see it coming together. So this is an emission nebula in Orion, near the Orion Nebula. And I mentioned, before that our Iris Nebula that we're looking at, that is a type of reflection nebula. This is an emission nebula. And so this is the gas itself is glowing and giving off this light that we're seeing. And it's a lot fainter than the Orion Nebula, which is another kind of emission nebula. In fact, like the Orion Nebula is so bright that you actually can't see the center. Like it's all completely overexposed, that center part called the trapezium. But the Flame Nebula is fainter, and I'll let it go for, we'll do 5. That's enough. And I'm starting to see light pollution coming from the moon. Ideally, the moon is just coming up now, and it's like just a couple of days after the full moon. So you can see the gain on it. But we will move fast for the moon completely. Actually, we'll just power through it and look forward to times when the moon isn't up. Okay. So the Flame Nebula is a little bit farther away than the Orion Nebula. It's 1,350 light years. $350, yeah. Okay. Weird. Huh. Okay. Okay, that's better. That'll do. So what's cool about this picture is that you've got this sort of central dark dust lanes that are coming through the nebula. And then you've got the emission nebulae that's around it. And of course, it looks really good. It's about 12 light years across. And like I said, about 1,350 light years away from us. And it's just another nebula. All right, now we're going to see a different kind of object. We're going to go look at a planetary nebula. And probably the most famous, I guess the second famous, which is the Dumbbell Nebula. No! Oh, it's too low. No, that sucks. Okay. Are there any other planetary nebula I could look at? Cocoon. Nope. Oh, that's too bad. Oh, I can't see the helix and I can't see the... Oh, well. Let's try the crab. No, it's farther away. Okay, so we're moving on. We're going to go to the Horsehead. This is all in... yeah, we're going to do the Crab Nebula, but it's 7,500 light years away, so we've got a long ways to go. Yeah, don't worry about the battery critical. Battery's fine. It actually has no battery. It's plugged in. So the reason the battery is critical is because the battery has been removed. So Starfront is a telescope co-location place. So you rent a pier, you rent a post that you put your telescope on, and then you send them the telescope, and then they set up the telescope, and then every night they open up the roof to this observatory in these really dark skies, and then you get a chance to see, like, you get to sort of use your telescope remotely through the internet. And it's coming in, but I think I'll call it there. I definitely see it, but I'm definitely getting some light pollution. And you can see the flame now. That's awesome. You can see the flame nebula up in the corner there too. They're very close to each other. All right. And I got a Starlink. All right, I'll save this. Horsehead is 1375. So they're all in the same area. Okay. So, and I'll show you the full view. Now, this could be much better. And so that object in the upper left-hand corner, that's the Flame Nebula, the one that we just looked at. That's awesome. All right, let's go to the Running Man Nebula. Also in the same area. What? Not the Running Chicken Nebula. That would be awesome, though. But it's not visible from here. Running Man. What? Okay, maybe it's got another name. NGC 1977. Okay, let's try that. Not the Running NGC 1977. There we go. Yeah, no, it's a real nebula, the Running Chicken Nebula, but it's only visible from the southern hemisphere. That's weird. What is that? Okay, I'm going to stop that. What is that? I've never seen that red blob before in the middle of the sky. I'm going to discard that. That's really strange. Let me try again. I wonder if there's a problem with the imager? Or is it like the moon is causing a... That's weird that it turned orange. Yeah, there it is again. How strange is this? And then there's like a couple of... What? What am I looking at? This is the drones. Huh. I found a new sun. I'm going to totally save it now. Yeah. All right. I'm going to save this. And that's all I can think of. Yeah. Like it's stray light that is coming into the telescope somehow. Like it's too close to the moon. Like I think the moon is just on the to the right of the image. Weird. All right. Okay, I'm going to stop this. Yeah. And we'll see what the picture looks like. But so all of these, like this glow around it, this is part of what you get from the light pollution caused by the moon in the sky. Maybe there's like a faint... Let me look at the picture at Starfront. Maybe there's a clouds. I can definitely see the... Wow, that's a nice picture. Okay, we might have a problem. We might end this evening then. Oops. Looking at... Yeah, it's in the picture too. Try this again. In the downloaded picture, but I'm looking at the image. Nice. That's my favorite picture. It definitely is the Running Man Nebula. Okay, let's take a picture of the moon then. If the moon wants to be part of this, then let's see if we can find the moon. Okay, so let me turn down the exposure. So it's dialing in the moon. So it's just changing the exposure down and it'll get it. Which is pretty cool that it can do this. My guess is it has like a special moon mode. There we go. All right, let's take a picture. Or not. Okay. Let's do. I don't think it'll work. I've taken pictures of the moon before, though. I have to do is the snapshot. Because it just doesn't even want to start taking the picture. Okay. So let's try the snapshot. Millisecond. Ten microseconds. It's a very short exposure. 100 microseconds. Try 300 microseconds. But I can't save it. It won't save in the same way. All right, it saved my camera roll, but if I can get a the image. Okay. The moon. 2 light seconds away. That's cool. The moon is about the age of the Earth, but like a little bit younger, like 100 million years younger. Awesome. So let's see if I can put that in there. All right. let's try the next object. But I think we're going to start, they're going to start getting bad. So we're going to do a star cluster now. So the moon, because the moon is like partly full, like it's almost full, it's going to cause some problems. All right, let's take a picture of this. We'll do 10-second exposure. So this is M34, which is, this is the first star cluster that we're going to look at. It's about 1,500 light years away, and it's nicknamed the spiral cluster. That'll do. I probably want to refocus it. You have to refocus the telescope, and as the temperature changes. So I'll do that now. So while and it's handy though, because it'll autofocus, but you know, every few images you want to sort of force the telescope to refocus. As you can see the stars are kind of fuzzy, and then it's sort of zooming in to find the exact right focus. I like star clusters. And these look really nice in a small pair of binoculars or a small telescope. And you don't really need to have like really nice dark sky to be able to see an object like this. Oh, there is no way this one's going to work. The Pelican Nebula. We'll try, but it's going to be so washed out by the moonlight now. I don't even know. I shouldn't even bother. Yeah, it'd be good to do, like it's best to do these kinds of things when there's a new moon, but it's also nice to get an image of the moon. So It's always tricky. People always want to see a picture of the moon. The best time is when it's like a crescent moon and you start the evening and the moon is still up. You can take a bunch of pictures and then the moon goes down and then you don't have to worry about the moon anymore. Yeah, Mars is in the view, and I took a terrible picture of Mars because this telescope is not good for that kind of thing. You can see in the list of images that I shared I pinned at the top, you can see the picture of Saturn, and that'll give you a sense of what Mars will look like. And Mars is at its best right now because Mars is at its like closest point right now. It's nearing opposition. And so this is also the sort of the launch window when you send missions to Mars. And the NASA's Escapade mission was supposed to fly to Mars on a Blue Origin New Glenn, the first or the second launch of New Glenn, but they had to push the launch back, and so now they're going to try and launch in March. And so Mars is very bright. Like right now, you go outside, and the bright red star that you see in the sky right now, that's Mars. Like if you walk outside right now, go look to the, near the moon, you will see Mars. Yeah, there's just too much light pollution to actually produce a proper image of the Pelican Nebula. I can tell. But this is how we learn. All right, that'll do. Every 2 years, you get a launch window to Mars. And so Blue Origin is kind of on the clock, right? If they can't launch a New Glenn by March, then they're going to have to wait 2 years before they can do it again. And I'm sure there's some kind of penalty in the NASA contract. All right, let's try the Ring Nebula, which might be below the horizon. Here's hoping. Oh, no. All right, I'm going to skip a bunch. Let's go to the double cluster. So now we're moving to 7,500 light years away. I'll download the Pelican. Yeah, nothing. I can't even see any nebula. I can see like a little bit of nebulosity in this image, but almost none. And I'll reframe the telescope to get a better shot of the double cluster. And this is one of my favorite objects in the night sky. You can see it. If you have nice dark skies, you can actually see this with your own eyes. But if you know, and if you have a pair of binoculars or a small telescope, it looks great. It's like two little sort of clusters of stars in the same field of view. It's really cool. All right. Yeah. Well, it's the the so the moon is putting out all this illumination, and it is reflecting off of just the atmosphere and light haze in the sky, and it's creating all of this light pollution. And there are filters that you can use that you don't see the light pollution from the moon. You can even like take pictures of astrophotography objects in the middle of cities with these filters. You just have to it blocks most of the light, only lets a few sort of spectra in, very specific wavelengths of light coming into your telescope. So you just have to do much longer exposures to be able to do it. Okay, so this is the double cluster. Come on, little telescope. Okay. That's nice. All right, so now we are, man, like the dawn of agriculture. So the light that left this star cluster left 7,500 years ago. So you're looking at, so it's thought that these clusters, is two separate clusters, and they are about 12.8 to 14.5 million years old. And like I said, about 7,500 light years away. And this is just an absolutely perfect object to look at with a small telescope. Maybe you guys want to have your economics conversation somewhere else. Just a polite request. So, I mean, I don't understand the question. What would be there that long ago? Like just the light from these stars left 7,500 years ago. All right. So let's go to the Pegasus cluster. If it's going to work. Nope. Okay, that's not going to work. All right, let's go to Andromeda. So now we're going to take a huge jump out into space. All right. So this is going to be a little washed out by the moon, but even in like real time. So this image that you're seeing right there, where you can see the center of it, that's in real time. $2.5 million. This is such a crazy galaxy. All right, that'll do. That's long enough. So Andromeda, the Andromeda galaxy, of course, this is the much larger galaxy than the Milky Way. It's probably twice the mass of the Milky Way. While we have a central supermassive black hole that's about 4 million times the mass of the sun, the Milky Way at the heart of Andromeda is 100 million times the mass of the sun. And Andromeda and the Milky Way are on a collision course with each other. So at some point in the next few billion years, the two galaxies will sideswipe each other, start to tear each other apart, and then begin the process of actually merging into one giant galaxy. And we'll show the other galaxy that's going to be part of this merger as well in a second. There you go. Not bad. Let's go out a bit. So now the light that we're seeing from this left 2.5 million years ago. And so like that's what, before the human being evolved? Which is crazy to think, right? We're seeing the light. Now, what's amazing about this image is that we are seeing dust lanes. You see those dust lanes in the sort of around the galaxy, the galactic core. And those are like dark dust lanes that are part of the spiral arms in the galaxy. And it's about 3 degrees in the sky. It's about 6 times the size of the full moon. So if you think about how big the full moon is, if you could actually, let's see. Yeah, if you could see, like Andromeda is very faint. Like if you go outside and you have dark skies and you know where to look, you can totally see Andromeda. It's like this fuzzy blob in the sky that you can actually see. And if it was like bright, then you would be able to actually see full, the size of about, imagine 6 full moons side by side in the sky, which is pretty amazing. And so that's 2.5 million light years away. And so now we'll look at the Triangulum galaxy, which is 2.6 million light years away. And that's the next big part. That's M34. No. M33. Yeah. And so that's the third galaxy that's part of the local group, the third large galaxy. And it's also called the Pinwheel Galaxy. And it's actually in the process it's actually one of the galaxies that you can see with the unaided eye as well. So you can see, like, Andromeda is easy to see in dark skies, and the Triangulum galaxy M33 is also possible to see, but it just takes better seeing and better eyes to be able to see it. I can just barely see it in the temporary image. But we'll see if it starts coming up as I do the first 10-second exposure. There it is. Definitely not as bright and as big as Andromeda. But in fact, there's a star-forming region in this galaxy that is just absolutely enormous, with huge stars, hundreds of stars that are a lot brighter and bigger than anything we have in the Milky Way, or anything we've seen in the Milky Way. It's called I don't know exactly which part it is, but there's a place called NGC 604, and it is one of the largest known emission nebula relatively nearby. And so at some point, the M31, Andromeda, Triangulum, and the Milky Way will all merge, and then all of the various satellite galaxies will join us, and then we will become a giant elliptical galaxy. And that's 2.6 million light years away. All right, that's enough. Battery crit. Don't worry about the battery critical. Battery's fine. Okay. While that's coming, I'm going to try NGC 2403. Now we're moving into, I don't know if they're going to be able to get this kind of stuff, but we'll see. So there's the Triangulum galaxy. And again, the light pollution is definitely having an impact on our view. So I'll try this galaxy, NGC 2403. And this is 9.7 million light years away. Well, there's something there. Okay. Oops. .7. All right. It's like a minute exposure. That'll do. All right. So now we are starting to get fairly small. It's cool though. So that's a galaxy that is almost 10 million light years away. Let's go farther. So let's try a galaxy, and I have no idea if this is going to work. That's 225 million light years away. Two 262. Is this going to work? Okay. Again, I have no idea if this is going to work. There you go. Platypuses hadn't developed 9.7 million years ago. That's awesome. So this is Abell 262. And this is a galaxy cluster. It's about 200 million light years from Earth. It has about 100 separate member galaxies, all part of the cluster. I could see some of the bits and pieces of it. Okay, this is going to work. And the brightest galaxy in it is called NGC 708. It's part of the Perseus-Pisces supercluster. Yeah, there they are. This is awesome. Oh my God, I had no idea that we could do this. I'm so excited. There's 100 This is my own deep field. The Fraser deep field. Okay. That'll do. And also, this contains a gravitational lens, which is cool. And we're seeing it with light pollution from the moon. So this would be a lot better if there was no stupid moon. It's the dawn of time. All right. So I don't know if this is coming through, but you can see there's a spiral galaxy in the middle there. There's a bunch of other galaxies. 2 125 million light years away. So that's about the same amount of time that it takes for the Milky Way to turn once. And so when the light left Abell 262, the Milky Way has turned one complete time once on its axis. You can tell the moon I said that. Yeah, the moon knows what it did. All right, I'm going to try one last object, and then I think we're going to wrap this up, and that's the Tadpole Galaxy. And I have no idea if this is going to work. This is 400 million light years away. Oh, Tadpole. No? Okay, what is the tadpole? Does it have another name? I don't think it's going to work. Okay. Right. Oh, it's below the horizon. Oh, well, that's it then. I guess we have to wrap this up. Awesome. Is it going to work? Okay. All right. Well, thank you, everybody, for hanging out with me tonight and going on this time travel journey through the cosmos. Obviously, we had some challenges. Now, all the pictures are just going to remain in that Google Drive folder, and I've named them. So if you want to download them and check them out and scan them for information, you're free to do so. Super fun. Again, we continue to test using this technology. Thank you so much to the moderators who showed up. Thanks to Starfront for sharing this telescope and the facility with me to be able to do these live streams. And the moon can get lost. Hopefully then, we're going to do this again in a few more nights, and then hopefully the moon will be gone and we'll have much darker skies, and I'll bring on some guests. So this is sort of the new unfolding thing that we're going to be doing here on the channel, bring on people with their own telescopes from different parts of the world, as well as just, I'll bring on scientists to talk about some of the objects that we're looking at. So it should be a lot of fun. I hope you enjoyed this. And everybody take care, and we will see all of you Monday for the next live stream. All right. Thanks, everyone. We'll see you later. Where's the button?